Hello, this is the a quick follow-up to the last video I've done on the DC load. If you recall, if you did watch that video, you'll see that that the first power supply I used that I've previously repaired actually exploded when I tried to use it, and I've just taken that power supply apart and had a look inside. And actually, to be honest with you, I'm a little bit stumped. The power supply definitely failed. Both output devices have gone short circuit. But the nature of the explosion was it was actually quite a big, loud bang, and very typical of a component failing catastrophically and exploding or tearing apart, or maybe a capacitor exploding. And actually, I can't find any evidence at all inside the power supply of that kind of event, which is just really, really strange, because I absolutely definitely heard it and definitely saw the flash. I have looked also inside the DC load, because that was sitting underneath the power supply when it occurred. There's no damage in there either, or there's no obvious signs of an explosion. So and I've checked all the cables that I was using, and I can't find the problem. So I can't see where it failed, but the power supply definitely failed. Couple of things I have noticed about the power supply though. The first thing is there was a 6.3 amp fuse, mains fuse in there, which really should have been 3.15 amps. I hadn't noticed that before, so that's how it came. I assumed it was the right value. I probably ought to have checked that. And the second thing is, on the having removed the two power devices again and the associated heatsink, I'll put the camera on it in a second and show you. The gate pin for the power device that's used as the pre-regulator, the switch, actually there must be a hairline crack between the pad, almost certainly caused by removing the device and taking it in and out a couple of times. So what's happening there is the pre-regulator isn't working, and the gate is floating around, and the FET is naturally turning itself on. Which is obviously really not bad, not a very good situation. I don't know what impact that would have, and perhaps that's the fault. Anyway, I'm just going to point that out. I'll show you what I've done, and then I'm going to go and do a proper repair on it, show you that very briefly, and then what I'm actually going to try and do is I'm going to set the original test conditions up using the DC load with the scope, with the power supply, all that in bits now. And if there is any explosion or any other similar event, hopefully we'll catch it on video, and we can have a look at it and see what's going on. Okay, so you can see what I've done. I've removed the heatsink that normally holds these two power devices, and I've simply soldered the transistors in, or the FETs in, just so I can test it. Obviously under no load, very little heat is dissipated. In fact, there is a constant current source on the output, so this is the pass transistor, the regulating transistor or power FET. And it gets reasonably warm, so I've just put a temporary heatsink on it. I've also got the original heatsink I've removed, which has the fan fitted to it. I've just got that sitting here in the back. You can see that there, and that's just blowing some cold air across the whole thing just to keep it warm while it's on. So all I've done to this power supply, apart from take it apart and spend quite a lot of time visually inspecting it, looking for that failed component, which I absolutely can't find, which is just very, very bizarre. I've replaced those two output devices and powered it up, and it's working. So I'm going to just quickly show you that working. Now, before I do, I just want to describe the faults that I can find. This is the gate to the pre-regulator FET, this pin right here, and that small track there running to resist R46 there is a break in that. Now I don't know where that is. Basically, if I put the scope lead on this pin while it's running, after a second or so, the output drops and disappears to nothing. Yet when I and there's I'm not reading any voltage on here. So what I'm doing is I'm bringing the gate down and turning off this device. Now that's because there's a break in there. If I actually meter or put a scope on here, on this side of R46, there's the correct drive signal, the kind of drive signal I would expect. And actually, while it's running, if I press this down and get that movement, I can then suddenly audibly hear the pre-regulator running, and it kind of sounds like a 20 hertz sort of kind of a dull clicking sound, and so just by doing that, so clearly that's there. What I'm planning to do for both devices, because in both cases the gate on both devices has a very thin track coming from this at a right angle coming from this big thick pad. So I'm going to remove these devices, clean that up, and then I'm going to run a piece of solid wire from this resistor across the top of the board and down into the through hole, and bend it around on the other side and just tack it there. That way there's a permanent connection. I don't have to rely, and you'll see over here exactly the same setup exists. So I'm just going to, just for the sake of now I've seen that happen over here, just in case there's an issue here, I'll do the same exercise with it. It won't take very long, and it'll give it a much more solid reliable connection. All right, so I'm going to go away now. Just before I go away and do that, I'm just going to power this up and show you it working, and that's just by adding those two devices back. Again, on the output I've just simply put a 50-watt halogen bulb, so lamp, sorry. So just drive that to 5 volts, turn the output on. Okay, the overcurrent protection is tripped. We looked about that in the last video. Let me just reset that quickly. It's quicker to power it off and on than it is to go through the... What I'll do is I'll turn the output on and I'll bring it up. Okay, so there's our lamp running. There's the 5 volts, 1.69 amps. Everything's working okay. Switch to 50 volt mode. Yeah. Now, as far as I can tell, for mostly, I very much doubt you'll be able to hear it. But the pre-regulator isn't running, so it's there is a bit of warmth there. So right, I'm going to turn that off because it's not on a heatsink. It does actually run warm under load, so that's interesting. And I know it's definitely not connected there because it takes quite a lot of pressure to get it connected. So I'm going to go and do the actual the physical mechanical repair. Get the heatsink fitted back, so reconstruct it, put the caps back in. But I'm going to leave it set up basically like this, and then I'm going to hook up the DC electronic load and basically hook up the exactly same test scenario as I done when I tested it first time. I'm going to run the DC load in pulse mode, but I'm going to do all of that on camera. So if anything goes wrong and explodes, we'll at least get something possibly mildly interesting on camera. Okay, so I'm not sure how well this shows up, but basically what I've done here is soldered a thin piece of wire to the end of this resistor. You can see that silver there, which is a piece of stripped wrap wire, so very thin. Thin wire. Oh, you can see it there. So literally stripped and soldered in there, taken through the through hole. You can see the through holes are actually quite large. That's because of the positioning of the devices, and I've done the same here, just to make sure that there's no issue there with either of those devices. Okay, so I've got the setup here exactly as I had it set up before. I've powered up the scope and the DC load. I'm about to power up the power supply. What I'm going to do is I'm going to move the camera and get it looking at the overall thing, and I'm going to try and recreate the tests and see what happens. If anything goes wrong, it's not that easy for me to reach back behind to get the power. So if anything sort of bursts into flames or blows up, then I'll just let it do its thing. Okay, so here's the setup. Just to remind you what I've got set up here. I've got the power supply that I was originally using for testing. This is the thing that blew up before. Have replaced both output devices, which was what appeared to be wrong with it. So I've replaced those. Got the DC load here, electronic load, got the scope. The top trace is looking at the output, the voltage output on the power supply. The output is connected directly to the input terminals of the dummy load. I've also got the reference output at the back of the dummy load, which gives us a 0 to 10 volt signal for the current that's being drawn through it, and I've got that on channel 2, so that's here. So without being completely kamikaze, what I think I'm going to do is try some basic progressive loading on the power supply. Just make sure that that it doesn't sort of fall apart at the first hurdle, and then we'll try the pulse test, which was the thing that previously caused it to explode or go wrong. Let me just unfortunately the only way I can turn power supply on is to reach around the back. So if it does explode, I shall just step back and let it do its thing and reach around here casually. All right, so first things first, let's turn the output on. I think what I'm going to do, just for the purpose of these tests, I'm going to disable the overcurrent and overvoltage protection, just because it'll give us, it'll just confuse the results. Okay, so we've got no overcurrent, no overvoltage. The output's on. I'm going to bring it up to 5 volts. Just the starting point. There we go. We can see 5 volts in the load. That's great. I've set the load to be 1 amp, and I'm going to turn on the load. Hopefully, there we go. We've got 1 amp of power. Now, I'm not sure you can hear it. One of the things I can hear now on that power supply board is a kind of a buzzing, which is the sound of the pre-regulator pre-regulating. So hopefully that's working as it was. I'm going to just take the voltage up, and you can see that the dummy load is doing its job, continuously drawing 1 amp. I'm going to take that right up to its full range, 25 volts. So we're at 25 volts, so we're dissipating 25 watts, 24.96 volts. There's obviously some volt drop across the cables here, so that's working okay. Let's bring that back down to 5 volts. I'm going to do the same exercise again, except for this time I'm going to go into 50 volt mode. And I'm going to take it right up to 50 volts. Now that should give us, well, I probably won't be able to get that far. I'm going to take it up to 150 watts, which is what the DC load is rated at. No, that's fine. Yeah, so 1 amp, that's fine. Of course, 1 amp is 50 watts. So that's okay. So there we are. We're at 50 volts output, 50 watts dissipated at 1 amp. Okay. I'm going to turn it off, turn the load off, turn the load back on again. There doesn't seem to be a problem there. Now, next thing, let's get. So what I'm going to do now, I'm going to take the power supply. This is meant to be a 200 watt power supply, so I'm going to take this up to 150 watts, which is the limit of the load, and just make sure nothing falls apart there. Now, how will I do that? I will do that by turning the output on, and I'm on the amps here, so take that up to 2 amps. That should jump to 100 watts, which it has done, and up another amp, 150 watts. So there we go. Wonder what happens if I take it up to 4 amps. Ah, okay, so I'm over power. So okay, the DC load handles that. So that's 150 watts. Now someone did ask in the blog how well this thing will perform with having 150 watts dissipated into it. So what I'm going to do is I'm going to mark the time now, and I'm going to leave that run for let's say 2 minutes, and we'll come back. Hopefully the fan will be kicked in by then. Okay, so that's been it's about 2.5 minutes that's been on there. I'm surprised that the fan in the DC load hasn't kicked in yet, from what I can tell. I certainly haven't heard it. So we'll let that go a little bit more. Oh yes, sorry, it's idling. I can't actually hear it above the fans in everything else. Okay, so that seems to be comfortably dissipating 150 watts at 50 volts. So what I'm going to do now is bring that back down to 1 amp, and I'm going to try and get 150 watts dissipated into the load at low voltage here. So I'm going to take this into low voltage mode. Maybe run that at, what have we got? 7 amps. Okay, so that's 7 amps at 10 volts, getting 70 watts. That's working nicely. So if I take this up to about 21, should be able to get 150 watts. Yeah, 149.9 watts. kind of lukewarm air coming out the back of the dummy load, back of the DC load. Not a significant amount of heat at all. The output still looks regulated. This is DC, so that's the output you can see there, 21 volts. So 10 volts a division. Alright, so that looks good. So let's see if I can get you to hear the pre-regulator noise. I'm just going to move the microphone, sorry about the noise. Okay, I'm just going to put the microphone near the power supply because so you can hear the pre-regulator noise. Hopefully you'll be able to hear it above the fan. Yeah, it kind of sounds like a 150 hertz buzzing sound. Hopefully you can hear it on there. I'll check that in the edit. Alright, so the next thing to do then, I'll set this to 10 volts. I'll turn the current down on here. So the next thing to do, let me just put the microphone back. Okay, so the next thing to do is I'm going to try and set up pulse mode now. So we got 10 volts. No current limit, so 7 amps, 10 volts. Okay, so P. Okay, so I'm going to go from 100 millivolts, which is what I've done before, for 50 milliseconds, no rise time. I'm going to go to 4 amps for 25 milliseconds, no falling, and I'm going to go continuous. And this is at the point where it exploded before when I turn it on. So shift, tran, and on. Okay, so there we have it. It works. I really have no idea. I really can't reconcile the fact that I definitely saw something fail. I don't know what it was. It's not the DC load, it's not the power supply, I really don't know. The power supply is working now. You saw in the test I've done exactly the same as what I've done before, except for it was cased previously. Obviously it was in its case, now it's open. Everything works. I'm going to put it down to one of those things. It is my mystery explosion. So thanks for watching. If you enjoyed the update, please give the video a thumbs up, and I'll see you next time.